2023 Nobel Prize chemistry laureates, which involve discovering quantum dots, plasma televisions, LCD televisions, OLED televisions, biomolecular and medical applications. If you didn't know anything about quantum dots, the one takeaway, we have a big problem as it relates to detecting tiny molecules. Welcome back to another episode of the Crossover Connections with Jack Wang podcast. My name is Jack. I'm a college professor, scientist, YouTuber, and podcaster. Today's episode is all about the 2023 Nobel Prizes, which as of this moment are being announced and rolled out one by one. I'm not suited to talk about many, if any, of these Nobel Prizes, so I'm not going to comment on, for example, the Nobel Peace Prize or the Nobel Prizes in literature, but certainly all of these scientific Nobel Prizes have something that we can learn no matter what stage of our careers, whether they be in science or other fields we're currently in at the moment. And the hardest part about Nobel Prizes is it's difficult to see how a Nobel Prize discovery might relate to your everyday life. And so I'm going to try and break down the Nobel Prizes, relay what I know about these discoveries to people who are out there in the community, not really sure what us scientists are up to and what we're doing with these tax dollars that's funding all of our work. The first Nobel Prize is the one for chemistry, which involved discovering quantum dots. And if you haven't heard of quantum dots before, you can see this very colorful image if you're watching the video version of this podcast of all of these different quantum dots that are being engineered and are a prime example of nanotechnology, technology where it's invisible to the naked eye and it's on a scale of nanometers and is really microscopic things and little machines that are doing very incredible work at the sub-molecular level in many cases. If you didn't know anything about quantum dots, the one takeaway I had when I read through all of this material, the size of the dot dictates the color it will emit. And you could make it a bigger quantum dot and that will change its color. And this flexibility in which you can adjust the property of the dot in both its size as well as the wavelength of light that it will emit, that is tremendously flexible and tremendously powerful as a technology. It has lots of different applications. The one that may hit you the quickest will be the size and quality of the TV in your home. And the technology in TVs has progressed from plasma televisions to LED, LCD televisions, and now to OLED televisions. If you're lucky enough to have an OLED TV, individual diodes that have amazing contrast where you can see the blacks are true blacks. That little diode can turn itself off. The downside of OLED is that it's actually very expensive to produce. There are a lot of failed panels with respect to OLEDs. The yield for OLEDs is not 100%. So every time a single clean OLED panel for a huge TV is made, there are a lot of others that fail. So it's actually not very good for the environment. And also that makes the TVs that do make it into the shops quite a bit more expensive for you to buy. And the promise of these quantum dots, especially if we can manipulate the color of each dot so precisely, it will bring the cost of all of these TVs down. And it will also bring the size of the TV in terms of how thick the TV panel actually is. It will also bring that down as well. There is an article here from CNET. This top secret prototype display will blow your mind. Nanosys, a company whose quantum dot technology is in millions of TVs and it's on the precipice of replacing LCD and OLED TVs, maybe in your phones as well. And not only will we see a difference in the image quality, this will bring the cost of the average TV down even more. It will make those TVs lighter and thinner. The weight of these TVs is really unsafe. A lot of my doctor friends have people report to emergency rooms trying to install a TV by themselves as a single operator at home. So please don't do that. Hopefully this is an even more efficient technology so that the TV prices come down and there's less waste. All of this is very, very useful from a commercial perspective. Quantum dots are not just limited in their application to TV screens. They also have many biomolecular and medical applications. We have a big problem as it relates to detecting tiny molecules. Most of the time, technology currently allows us to attach fluorescent particles to proteins, to enzymes, to DNA, and we can track these fluorescent particles as they move through different biological systems, whether it be cells, bodies, or organs. Quantum dot technology, first of all, is smaller, quite a bit smaller than these fluorescent tags that we add on to these molecules. And the color is also a lot easier to manipulate because the size of the quantum dot dictates its color. It's a lot easier to prepare them. They're more consistent consistent within their uniformity, scalability, reproducibility. It also could include tracking certain things that are flowing through your blood. And this is where the future of clinical diagnostics could very much sit, to try and figure out where molecules are going in your body. So big congratulations to the 2023 Nobel Prize chemistry laureates. They added color to nanotechnology. I'm Jack. Hope to connect with you again in the next episode.